In this video, I will show you how to build a web application with ASP.NET Core Razor pages. By the end of the video, you will have an issue tracking web application that allows users to view a list of issues, submit new ones, and resolve existing ones. If you want to follow along, make sure to have Visual Studio 2022 and ASP.NET and web development workload installed. Let's go. What is Razor Pages? Razor Pages is a lightweight alternative to ASP.NET Core MVC for building web applications. It uses a page-based programming model that helps keep the UI and business logic concerns separate. In Visual Studio, create a new project. Select the template named ASP.NET Core Web App. Click Next. Give a name to the project and click Next again. Leave .NET 6 as the framework. Leave authentication typed to none. Unselect the option Configure for HTTPS because we don't need it. Click on the Create button to generate the project. Let's take a look at the files generated by Visual Studio. Program.cs is the entry point of the application. You can use this to register services for dependency injection. The file appsettings.json is where you store application configuration such as connection string, for instance. The pages folder contains Razor pages. This is where you will create the user interfaces. A Razor page is a pair made of the following files: a file with the extension CS.html. This file contains a mix of HTML markup and C# code. The second file, with the extension CS.html.cs, contains C# code to handle page events. The Pages folder also contains files starting with an underscore. You cannot navigate to these pages from the web browser. They are used to support the other pages. Let's see the purpose of each one. Layout has a high-level template for the views in the application. This is where you will place UI elements that are common to all pages, like the header and the footer. Validation scripts partial contains validation script in the form of a partial view. A partial view is a view that is rendered inside another view. View imports allow importing namespaces shared by many views. View star allows running code before each page. The following code makes all pages use the layout name layout. The folder www.root contains static assets such as CSS files or JavaScript files. Let's run the project to verify that everything is working correctly. As you can see, the web application is up and running. We will use a SQLite database to store the issues. Entity Framework Core will serve as the data access layer. We need to install NuGet packages before we can use Entity Framework Core. The first one is Microsoft.entityframeworkcore.tools that allow running migrations from Visual Studio. The second one is Microsoft.entityframeworkcore.SQLite, which is the SQLite database provider for Entity Framework Core. Once the packages are installed, we can create a model. Create a new folder and name it Models. Then add a new class inside this folder, name it Issue. Let's add some properties to the class. The ID property is the primary key. The title and the description are self-explanatory. An issue has a type that will be represented by an enum named issue. This enum doesn't exist. Let's generate it. The possible values are feature, bug, and documentation. An issue can also have a priority that will be represented by an enum named priority. Let's generate it. The possible values for priority are low, medium, and high. An issue has also a datetime property named created, which represents the date on which the issue was created. The issue class has another datetime property called complete. This property will contain either null, meaning the issue is pending, or will contain a datetime, which indicates that it has been resolved. Now let's set a default value for the title. I set it to an empty string. Let's do the same for the description. Now that we have a model, we need to create a data context, which is the object that interacts with the database. Create a new folder and name it data. Inside this folder, add a new class. Let's call it IssueDBContext. This class must inherit from the DBContext class. In the constructor, we are going to pass a DBContext option. This will allow us to configure the DBContext for dependency injection. Next, let's add a property which is a DBSet of issue. This property will allow us to interact with issues in the database. The DBContext is now set. Let's register it with the dependency injection container. Go to program.cs. After this line, use the builder object .services.addDBContext, and let's configure the DBContext so it can use SQLite. The connection string to the database is simply a path to a file. The database will be located in the path data/database/issue.db, which is the name of the database. So this path doesn't exist yet. Let's create it. Now it's time to create the initial database schema using migrations. To use migrations, I'm going to use the package manager console. I create a new migration with the command add migrations. I name my migration initial creation. And in the option of the command, I specify that I want to generate my migrations in the folder data/migrations. If I execute the command, you can see the command executed successfully. Now I execute another command, update database, which will create the database. If I go in the folder data/database, you can see that I have a file named issue.db. This is the database. We have a database. Entity framework core is set. It's time to display data using Razor pages. We are going to use the index page, which is the home page, to display the issues. Let's start with the page model. The logic we want here is to use the DBContext to fetch all the issues from the database and make them available in the view. Let's remove these lines because we don't need them. Next, declare the DBContext in the constructor. This way it will be injected at runtime by the dependency injection container. Let's add a property that will hold the issues. The type is IEnumerable of issue. Set the default value to empty so we don't have to check for null when using it. Now we need to load issues from the database, and a good place for this is in this method here, which is called onGet. This is called a handler. It is a method executed in response to an HTTP request. By convention, an HTTP request is mapped to a handler method in which the name starts with on, then the HTTP verb. Therefore, the onGet method, for instance, is the method that is executed when the page is requested with the HTTP verb get. This is a good place to initialize the state of the page. Let's load issues here. We want to load only pending issues, meaning issues that have the completed property set to null. We also want to sort them in by descending order based on the created property. When the page loads, the issues property will be filled with issues. Now let's display issues on the page. Razor is a mix of HTML markup and C# code. You transition from HTML to C# by using the @ symbol. For instance, we can display a message to the user when the issues list is empty. We need an if statement. In the condition, we want to access the issues property we declare in the page model. For that, we need to use this object called model, which will allow accessing the properties from the page model. We check if the list has 0 items. We display a message to the user. Let's try it out. Because the database is empty, I have this message, no data to display. Let's check inside the page model to see if the code is executed. Let's reload the page. You can see that the onGet method is executed first, and the issues list is empty. Now let's write some code to add some new issues in the database. Let's start by adding a link to the home page. This link will allow navigating to the form that will allow inserting a new issue. This is just a regular anchor tag. The ASP-page attribute makes this markup not an anchor tag anymore, but this is a tag helper. Tag helpers allow generating HTML elements dynamically. There are many built-in tag helpers for tasks such as creating forms, links, loading assets, and more. The ASP-page attribute is used to set the href attribute value of an anchor tag to a specific page. Let's add some Bootstrap classes to change the look of the anchor tag into a button. The new page doesn't exist yet. Let's create it. In the Pages folder, create a folder named Issues, and inside it, add a new Razor page named New. Let's put some text here. Add new issue. Let's try it in the browser to see if we can navigate to this new page. You can see the link on the home page. If I click on it, I got redirect to the issues/new, which is where we are going to put the form to collect new issues. Let's add a form to the new page. We need an HTML form. Set the method attribute to post, because we are going to use the HTTP post to submit data. Before writing any markup here, let's go to the page model that supports the page. In the constructor, declare the DB context because we will need it for saving data. Next, declare a public property called issue. This property will hold data submitted in the form. This is possible thanks to model binding. When working with Razor pages, model binding is the process of taking values from HTTP requests and mapping them to a handler method parameters or to a property of a page model. We need to decorate the property with the bind property attribute. Because we submit data using the post method, we need a method called onPost. Inside the onPost method, use the context and add the issue to the collection. Invoke SaveChanges async on the context to propagate changes to the database. Update the created property before adding it to the collection. After saving the issue, redirect the user to the home page. For that, you will need to change the signature of the method to return an action result. The page model is now ready. Let's complete the form. First, let's capture the title. We group labels and controls inside a div that has the class form group. This is the perfect way to structure the content in the form. We also use classes such as form label or form control to make the HTML element a little nicer. We will also use tag helpers to make the creation of the HTML elements easier. The label tag helper has ASP-4 attribute, which is useful to generate the 4 attribute on a label. It needs the title property from the model. We can also use the ASP-4 attribute on a input. Let's run the application. If you inspect the HTML in the browser, you can see that each HTML element has been generated with the correct attributes. Let's copy this group, replace the title with the description. Let's do the same for the issue type. But here we're going to replace the input with a select tag helper. This tag helper has an attribute named ASP-items, which allows setting the options. We will use a helper method named getEnumSelectList to display the issue type as the option for the select element. Let's copy this group for capturing priority. We change issue type to priority. Finally, let's add a button for submitting the form. Let's run the app. The form is displayed correctly, but I see that we have the wrong element for the description. Let's change it with a text area. Let's try again. Let's fill in the form. If I click on the submit button, you can see that the breakpoint in the onPost method is hit. If we check the issue property, you can see the title, the priority, the issue type, the description. If I continue to the home page, but there is nothing to see yet. So before displaying the issues, we need to do some validation. The first step for validating data is to decorate properties with built-in validation attributes. We can decorate the title with the require attribute to indicate that the property must have a value. The string length allows specifying the maximum length of the title. Let's apply the same attribute to the description property. Next, we perform server-side validation using the model state. This object will tell if the model is valid according to the validation attributes we set on the model. If the model is invalid, we want to return to the page so the errors can be displayed to the user. Otherwise, the model will be saved and the user will be redirected to the home page. To display errors on the page, we are going to use validation tag helpers. For the title, add a span element, then set the value of the attribute ASP-validation-4 to the title property of the issue model. This element will display an error if the title is empty or if the length is more than 100. Let's do the same for the description. Let's try to submit an issue without the title and the description. You can see the error message. Now that we have some data in the database, let's display them. On the index page, in the else statement, we are going to iterate over the list of issues. We will use the bootstrap card component because it has a nice look. Let's copy a template of a card in the bootstrap documentation. In the header section, display the issue type. In the card body, we display the title inside an anchor tag helper. The ASP-page attribute is set to a page that will display the detail. We will create the page later. We had a new attribute we have not encountered yet, ASP-route-ID. This allows us to add the ID in the route. I want to use the bootstrap badge to display priority. It will be cool to display a red badge when the priority is high, an orange badge when the priority is medium, and a green badge when the priority is low. For that, let's create an extension method for the priority enum. Add a new folder named extensions. Add a new C# class in this folder named priority extensions. The class must be static. Add a new method named toCSS class. The goal of this extension method is to return a string representing CSS classes to use in order to display a badge. The method takes a priority enum. Do not forget the this keyword. Now let's declare a dictionary that will map a priority to some CSS classes. The method toCSS class will look up in the dictionary to find the priority and return the corresponding CSS classes. Let's return to the index page, update the class attribute of the element that displays priority to use the extension method. In the footer of the card, display the created property. Instead of displaying a boring datetime, we are going to add a NuGet packages that will help display a more friendly date. The name of the package is Humanizer. Once installed, we can invoke the method humanize. Let's see the result. Issues are now displayed. On the home page, we display just a few properties from an issue. We want to display all properties on a detail page. Let's create a new razor page inside the issues folder. Name it detail. On the page model, declare the data context for injection. in the onGet method, use the data context to fetch a single issue based on the ID and assign it to an issue property. When the method will be executed, the model binder will populate this parameter with the ID in the route. In the page directive, add a string between braces id:"int". This is called a route template. It tells the framework that the first segment of the URL after the page name is a route parameter named id, and its type is int. Before displaying issues property, first check if the issue exists. If not, display a message to the user. Let's try out. If I click on an issue, I am redirected to the detail page. Of course, the page is empty. We haven't write code to display it. Let's change the ID in the URL to something that doesn't exist. You can see that the message issue not found is displayed. Let's return to the page. Display the title in a heading markup. Display the issue type inside a badge. And do the same for the priority. The value of the CSS class will come from the extension method created earlier. Display the created date in a friendly fashion using the humanize method. Display the description. And finally, add a button that will help resolve an issue. Let's see the result. Issue detail is displayed correctly. Now let's manage the action beyond the resolve button. In the detail page model, add a new method named onGetResolve. It receives a parameter of type unsigned int, which represents the ID of an issue. This method is called namedHandler. It's a handler named resolve that can be executed in response to a HTTP GET request. Because we declared a parameter, that means that the request can provide a parameter. Let's launch the app. Navigate to the detail page. Here, update the URL and add $handler equals resolve and ID equal 2. If I submit this request, you can see that the breakpoint in the onGetResolve is hit. So let's write the logic to resolve an issue. First, we fetch the issue we want to update. Then we set the completed property to the current date time. And we save the changes to the database. Because the resolve button is not in a form, we will submit the request with JavaScript. Let's add a section named scripts. If we take a look in the layout file, there is a method render section async that is invoked. The first parameter is scripts. On the detail page, creating a section named scripts means that the code in this section will be rendered on the layout page. In this case, it's a way to load a script at the end of the layout. The script uses jQuery, so we make sure the DOM is ready. When the Resolve button is clicked, we retrieve the ID of an issue through a custom attribute. Let's name this attribute data-issue ID. Then we send a GET request to the named handler Resolve. After the handler is executed, we display an alert and we set the URL to the home page. Let's see the result. If I click on the Resolve button, you can see that the handler is executed. The alert is displayed, and I got redirected to the home page. And on the home page, you can see that the resolved issue is not displayed anymore. This tutorial ends here. You will find the link to the code in the description below. I hope this tutorial was helpful to you. If it was, please like the video and subscribe for more. Thanks for watching. See you next time.